I'd like to thank you for coming to this webinar for the HTW expanding our line of the Tempuflo pumps. If anyone has any questions, there will be a slide at the end with an email that you can refer all your inquiries to. The HTW was released by engineering in 2015, just recently. The pictures you see here are the first production run of the HTW pumps. The picture you see there on the left is without the shield. This is showing you the heat exchanger coil. This is the one major piece that makes the HTW possible. The picture on the left shows the HTW 80, and the picture on the right with the shield actually shows the HTW 300. These are, again, the first production run of this series of pumps, the HTW expanding the Tempuflo line. This heater coil that we'll show in greater detail later is what it's doing is it's taking water from the sealed chamber and it is circulating it around the heater coil and back into the sealed chamber. We'll explain this in greater detail later, but I just wanted you to be aware of what you're seeing here. The Tempuflo is a registered trademark. It is a name that we came up with here to describe our series of pumps, the HTW and the HTO line of pumps. The HTO, which you already are familiar with, the hot oil pumps, and the hot water pumps, the HTW pumps. Here at MP Pumps, we did patent this design. Several of the features, not only that heat exchanger coil that you've seen earlier, but several other design features inside this Tempuflo family have been patented. Now, we don't want to limit the use for this pump, but specifically when we're designing this series of pumps, the HTW that is, we designed them for use with water, ethylene glycol, propylene glycol, and triethylene glycol. These pumps come in 4 different distinct models. The HTW comes in 80, 120, 180, and 300. The 80 and 120 both come in 2 different models. The NPT and the flat flange. This has a very durable design. The design of this comes in the standard ductile iron construction. Also, it comes with our severe service seal. Our severe service seal has the materials of carbon, silicon carbide, mechanical seal that is, and the O-ring seals are Viton and elastomers. As always, you can always change the orientation of the discharge on these pumps. That can change from a vertical or a horizontal discharge position. This is showing you the difference. The 80 and 120 come in 2 different variations. The 180 and 300 only come in ANSI 150 class flat flanges, but the 80 and 120 come in NPT as well as the flat flange choice. And this is still offered in all of our variations. The HTW will be offered with a C-face electric motors, also without the electric motor, known as the pump pack, or with a pedestal mounted bearing unit. The HTW line of pumps is self-aligning. It's self-aligning in that you don't have a long coupled design. The fact that it is close coupled gives you this self-aligning attribute. This is because of the close tolerances that are put onto the adapter and housing and impeller to allow it to be self-aligning. So with the long coupled unit, you'd have a bearing assembly and pump and electric motor that you'd have to align with a coupling. This close coupled design eliminates all of that. This unique patent design, which features a high temperature, low thermal conductivity materials, all of this combined with that heat exchanger coil is what reduces the amount of heat loss and keeps the bulk temperature in the main region of the circulation of the fluid that you're pumping and out of the seal chamber. With this series of pumps, we can process temperatures up to 400 degrees Fahrenheit. What this is showing here is a cutaway of the HTW 80. And the first thing that I would like to point out is just this color gradient here. This is showing you how the bulk temperature can be extremely high, up to 400 degrees Fahrenheit, and the seal temperature will still be relatively cool in comparison, this showing 190 degrees Fahrenheit. This all is accomplished by several things. Some of the things that I want to point out first are the things we integrated over from the HTO line. The HTO had these isolators right here that I'm showing, and these are made out of a low thermal conductivity material, carbon graphite. That plus the labyrinth of the drive seal itself is two of the main reasons the HTO line of pumps was able to maintain a high bulk temperature but a low seal cavity temperature. But there's some other things that made the HTO line good as well. Like I talked about before, this is a close coupled design, meaning that the electric motor directly drives into the pump itself. And this is accomplished by these close tolerances on the adapter and the housing and all the other components that drive this concentricity. The pump pack design allows for an easy assembly and impeller clearance. The impeller clearance that is set on the Tempuflo line of pumps is extremely easy to set. All that is required to set the impeller clearance on these series of pumps is to have the fan clamp loose. This is the fan clamp here, and to assemble in your electric motor. Then, while the electric motor is fastened onto the adapter, then pressing on the end of the impeller until it bumps up against the isolators back here, you can tighten down on the fan clamp, thus setting your impeller clearance. And this can be done with or without the housing on. This is an extremely easy impeller clearance to set up, and it's different than some of our other designs, but this is definitely one of the easiest to set the impeller clearance on, and that is maintained in this HTW design. What this is showing you here is this is actually the ANSI 150 class flat flange design, but this is the model that also has the NPT as well. The fan clamp that I mentioned before, this not only clamps down on the drive sleeve itself, but it also aids in cooling the seal chamber itself. This seal chamber has a series of fins around the diameter of the seal chamber, and this fan clamp aids in the cooling of the seal chamber itself. Those are all the things that are integrated over from the HTO line, but some of the things that have changed to make the HTW a possibility are a couple of changes in that we added different gaskets that are suitable for hot water application. Also, O-rings have been added as well. The main change that has happened here, though, is the addition of this heat exchanger coil that you can see in the cutaway here, as well as the picture you've seen before. This takes fluid from the seal cavity itself, and this NPT port down here you can see takes in and out from the other side fluid from the sealed chamber. Then it circulates it around the heat exchanger coil, and the fan from the totally enclosed fan electric motor cools as it blows air across the heat exchanger coil. And then the shield is still offered, but it not only covers all your rotating components, but it also protects and covers the heat exchanger coil itself. And this is just the cutaway from SolidWorks. That's the program, the 3D software that we use here. This is a snapshot showing you that we have the HTW. If you look on our website later, you'll actually see all the information for the HTW series of pumps up on our website. And from here you will be able to get important information about the construction and installation instructions, but also prints as well. You'll be able to see installation prints. You'll be able to see explosion parts view of all the parts list in these series of pumps. And you'll be able to see just all the information you need to know for this, as well as specs on the heat that it can take and anything else you need to see. If there's something you don't see here, please contact customer service and we'll be able to answer any questions that this does not answer. This is an example of one of the things you can see on there is the installation print itself. And this gives you the dimensions you need to hook this up to your system. We also offer 3D solid modeling for those that want to integrate a solid model into their 3D software for their assembly and for their designing of their system itself. What this curve is showing is all of the family of the HTW pumps. This is on a logarithmic scale, and so it goes up by a factor of 10. And so you can see here that it just goes up from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on and so forth by a factor of 10 every time. And this was done just so you could see all the family of pumps on one graph and keep it clean. This graph is used to just a quick reference to see what pump best suits your need from a flow. This is flow on the bottom x-axis here in gallons per minute, and pressure or total dynamic head on the y-axis. So once you establish where you're needing to be with your system, you can quickly figure out which pump best suits your needs. This is a normal graph that you can see from a pump here. This is just one example. This is the HTW 180 pump, and the size is given in the top right as well. The suction on the HTW 180 has a 3-inch suction and a 1.5-inch discharge, and the impeller diameter is listed here as a 6.45-inch diameter. Now this is a constant diameter curve, but it's what we call a multi-speed curve. When you lower the speed of the pump itself via using a variable frequency hertz drive, or if you just have a 50 hertz application or you have a slower electric motor itself, this dramatically changes the pump performance itself. And that's what the multi-speed curve shows. As you change the speed, the pump performance will change. As well as the last graph, this is still gallons per minute on the bottom and total dynamic head on the left. And the metric conversions are on the opposite sides. What this is showing, these curves are rather busy, but they're showing you pump performance on these curved lines. These curved lines that are going in this direction are the efficiency lines, and the constant horsepower lines are going in this direction diagonally. The opposite diagonal lines are your net positive suction head required lines. This is just one example of a pump curve. We have pump curves for every model that we've seen before. What this curve is showing is the performance you can expect from our system from taking the bulk temperature into our seal cavity temperature. The bulk temperature, or the temperature that you'll be pumping in your system, is listed on the x-axis on the bottom in degrees Fahrenheit. The y-axis, on the other hand, is what you would expect to see if you had a temperature gauge in the seal chamber itself of the seal temperature in degrees Fahrenheit as well. So for a given bulk temperature, what is the range I can expect to see depending upon factors of what my seal temperature will actually see? And this range is based upon all of the HTW pumps, and they all have slightly different seal temperature performances at a given bulk temperature, and that's why you can see the range here as well as varying performances as well. But this range shows that seal temperature versus bulk temperature. What this is showing is the overall limitations of our HTW pumps. How high in temperature can you go, and how high of pressure can you go? On the x-axis we're showing temperature in degrees Fahrenheit, and this is the bulk temperature of your system, not the seal cavity temperature. And what can the bulk pressure be as well? The answer is the highest limit is different depending on which pump design you get or want. This HTW 80 is on the top, and HTW 120 NPT is on the top. The differences are the style of the housing itself. The NPT design actually bumps it up into the ANSI 300 class. The flange is a 150 class, and so that gives you a difference in limitation, as well as the difference in limitation is also restricted to the mechanical seal itself. Each mechanical seal, depending on its size, has a limitation of maximum pressure that it can handle. The smallest seal can take the greatest amount of pressure due to its surface size. So the HTW 80 actually has the highest pressure rating at a given temperature that it can accept. So this is showing you the NPT version of 80. This is the 120 NPT, but this one curve, this dotted line, represents 80 and 120 for the HTW with the flat flange. And the flat flange is only offered in the 80 and 300, and that's the line you see here. The major limiting factor again is the mechanical seal. This is just a curve for reference. This is the liquid vapor line that you must maintain in order to maintain a liquid. As you know, water evaporates or vaporizes at 212 degrees Fahrenheit at sea level pressure. But if you want to maintain liquid, you must be above this pressure line here. So this is showing you what that pressure must be in order to maintain a liquid, and in order for your bulk to not be vapor. Obviously, this line will move based upon what your fluid actually is. This is just showing water. If you're using one of the ethanols or glycols with water, the line will be moving to the right. That's just showing you your overall pressure and temperature limits. This is just a quick chart, and it's a great chart. You will be able to have this available as well for you guys. This is just a quick reference chart, and what this is showing you is what are the general sizes that you can expect for each pump design, giving you the suction and discharge size, and then the size of the impeller itself. So you have the suction and discharge, and then the impeller, and what they're offered in as far as flange design on the housing. Also, what electric motors can be hooked up to these pumps. And this helps when you're especially buying a pump pack design, and which, if you already have an electric motor on your shelf, this will aid in which pump will be able to hook up to that electric motor. And it also shows you the maximum capacity in gallons per minute and the feet of total dynamic head that you can expect out of each design. Now, what are some of the benefits that you can expect from the HTW line of pumps? Like we said before, this has all the benefits that you're used to seeing with the HTO pumps. But with the heat exchanger added, this reduces that seal housing temperature to increase mechanical seal's life. The cooler we can keep our mechanical seal, the longer it will last. And all these things combined that we've seen is anywhere from 60 to 80 degrees change with the heater coil added. This was seen, we did a test where we actually valved off the heat exchanger while we were running and allowed it to maintain an equilibrium temperature. And then we turned it back on and allowed it to maintain an equilibrium temperature again. And this is how we've seen this, how effective this heater coil really was, because it really showed us with and without flow through there how effective we were with just the addition of the heat exchanger coil. So with this isolator technology combined with the heat exchanger, the seal cavity can stay under 168 degrees Fahrenheit while the process heat is at 400 degrees Fahrenheit and the bulk temperature. What these two pictures are showing again is the HTW 300 and the HTW 80 for the first production models that we've created. Now what's the difference? What's setting us apart from the competition? The HTW pump is going to save you in water cooling cost. This has to do with if you're going to have a lot of other competition's designs will actually have an external seal flush. This external seal flush is adding extra and unnecessary parts to your system, as well as that extra water going through your system could lead to calcification in your plumbing itself. All these cooling water costs plus the water itself, the bill of having the extra water being pumped through the system, is all eliminated with the HTW design. This is an efficient design with the enclosed impeller and everything being close coupled. It is a very efficient pump, and so this will mean less energy costs for the consumer as well. Another benefit of having this close coupled to the electric motor, it does not need an internal bearing. The internal bearing is needed by some of the competitors because of how long their overall system is, and they need to hold up the opposite end of the impeller. The HTW design is a very compact design and does not require this additional bearing, and therefore is one less part in the system to fail. And so this is a very efficient design as far as floor space and this elimination of the extra wet bearing in the competitor's design. Now, what are some of the applications for the HTW? The HTW can be used in various different applications. Why would you use water or some form of water with the HTW? The water itself, as you know, is extremely good at transferring energy. Its thermal conductivity is very high. When added with other additives, it goes down, but it can be up to 4 times the thermal conductivity from standard heat transfer fluids, and it is very efficient at transferring heat across the system. What are some of the applications, though, that this can be placed in? Well, once again, we don't want to limit what this can be put into, but just to give you some ideas of what we thought this could be put into, was anywhere that hot water is used for transferring energy. This could be anywhere where water is required, like in the food and beverage industry or pharmaceutical processing, biogas and waste water treatment. There are some instances where you cannot use an oil that could contaminate into their system, and you must use something safe. And these applications would require an HTW design. Places that would use this would be hospitals, universities, prison, and healthcare facilities that transfer energy with water. Chemical processing, commercial laundry and heating use this type of system. Like I said, anywhere that uses energy conversion, where you take a fluid and you're transferring heat across the system, this is a great pump and a very robust design for these applications. Right now in our website, we have bill of materials already loaded and ready for order. These are just a few of the choices that you can see from our website and also from our customer service that you can call, that shows you the pumps that are available already and ready to go. This, in case you're not familiar with our nomenclature here, this is showing you the part number itself for the pump that you'd be ordering, and then the description itself for the pump. This is showing you HTW pump and ductile iron with the horsepower and then the phase of the electricity. This is a 3-phase electric motor. This is the NEMA size of the electric motor itself, 56C. This is the diameter of the impeller, as well as the seal choice And this is a flat flange design, and the discharge is in the horizontal position, just to give you an idea of what some of our nomenclature means. If you have any other inquiries, please contact customer service, and they'll be able to, if something is not quite fitting your needs, they contact customer service and they will be able to supply you with either a new part number or the part number that already exists that fits your needs. We'd like to thank you for attending this webinar, introducing our brand new pump, the HTW, to you guys. If you have any questions, please contact us. This is an email where you can send all your inquiries to. We thank you for your time.